Hi guys, now we're going to be finding something called the area of a segment, which you're probably like, that doesn't make any sense as long. A segment is just something that joins 2 points together. It's like a piece of a line, right? Well, in terms of area, let's talk about what it means to find the area of a segment. So we'll go back to that nifty prezi. Alright, so the area of a segment, so a segment in a circle is a region bounded by an arc and a chord. Okay, so we're going to have an arc and a chord, and it's going to be the region in between the chord and the arc. Okay, which the way that we're going to be finding the area of the segment, we're basically going to find the area of the sector that joins the chord. So like if you were to connect the chord right here, we're going to find the area of that sector that surrounds the chord. And if we remove, so it's kind of like this. So here's, the whole thing is the sector, which the sector will start and end where the chord starts and ends. If you remove this triangle, which is underneath the segment, okay, if you remove the triangle, the segment's what's left. So we're going to do the area of the sector, which we already know is pi r squared times x over 360. And then we're going to subtract out the area of a triangle, which if you didn't know, the area of a triangle is 1/2 times the base and the height. Okay, the b is the base, the h is the height. Now we got to be careful with the height of a triangle. The height of a triangle must come from a perpendicular segment. Okay, if it does not come from a perpendicular segment, it is not an accurate height of the triangle. So if our triangle doesn't have a perpendicular segment, which means to intersect another line or segment at a 90-degree angle, that means we're going to have to draw in our own perpendicular segment, which if you think back to when we did the area of a triangle, when we did segments and triangles, and altitude is a segment that starts from a vertex and hits at a 90-degree angle. Okay, so we'll be drawing in an altitude to help us find the height if we don't already have a perpendicular segment. Okay, so let's get going, you guys. This looks exciting. Okay, so we're going to be finding the area of the segment. Okay, so basically in this one, it's going to be what's highlighted, which I'll kind of zoom in more on this problem so you can see it a little better. Okay, so I'm just going to write out the formula real quickly to help us. Okay, so the area of the segment, which I'll abbreviate with a seg, that's area of segment, equals the area of the sector, A sub SCC, area of sector, or I guess I could write it sector, minus the area of the triangle. Okay, so the area of the segment equals the area of the sector minus the area of the triangle. All right, let's get going. Okay, so a seg, area of segment, equals the area of the sector, which we know is pi r squared minus the fraction of the area times the fraction of the area we're dealing with, which you could put that in a parenthesis if you wanted. Okay, then it's going to be minus the area of a triangle, which is 1/2 the base times the height. All right, so let's get going, you guys. So the area of the segment equals pi times my radius squared. Okay, which the radius, if we look back here, is 4 centimeters. So I'm going to fill that in. 4 squared times the degree of our central angle, which this little box thing right here means it's 90 degrees. Nice. So it's going to be 90 over 360. All right, and then now we're going to focus on this triangle right here. Sorry, I'll close these out. All right, so minus 1/2 times the base and the height, which remember, you guys, the base and the height must come from a segment that is perpendicular to another segment. That'll tell me which side is the base and which side is the height, which if you see, I spot 2 perpendicular segments right here, See how there's this 90-degree angle? Okay, so I'm going to call this my base and my height of the triangle, what I'm solving. Okay, so that's the base and the height. So the base is going to be 4 centimeters. So let's see, times 4 times my height, which the height I don't currently have. Oh no. Do you guys see anything in the picture that might help me to find my height? Well, the height is technically the radius of my circle, which do you spot another radius in the circle? Because that would help me find it. It is this 4 centimeters right here. So that means the height is also 4 centimeters. Whoa. Guys, so my base and my height in this triangle are 4 centimeters. So it's going to be 4 times 4. All right, so the last step is just to simplify this all down, which the way I'm going to simplify it's going to look weird because we're going to leave pi in our answer, but it's okay. We're okay with weird. Weird is perfectly acceptable in math. Okay, so let's just simplify this bad boy down. So we have the area of the segment equals 4 squared, which is 16, so it's 16 pi. Okay, I'm going to kind of try to reduce this down right here because I didn't really save a lot of space to reduce that fraction down. Okay, which... remember, if you divide by 10, it eliminates 1 0 in each fraction. So each of these zeros will cancel out, as well as my degrees. My degrees cancels out. So I'm left with 9 over 36. So what's the number that divides into 9 and 36? Oh my gosh, you guys are so smart. 9 does divide into both. So I'm going to divide both sides of my fraction, my numerator and denominator, by 9. Okay, so 9 divided by 9 will be 1. Which, let's see here. Do it in this color. It'll be 1 over 36 divided by 9 is 4. So we're dealing with 1/4 of the circle. Cool beans. All right, let's keep going. And then minus half of 4 times 4, which 4 times 4 is 16, and half of 16 is 8. Or you could like put all these over 1 and multiply across. So it's 1 times 4 is 4, times 4 is 16, over 2 times 1 is 2, times 1 is 2. So it's 16 over 2, which is 8. So we're subtracting 8. Bam. All right, let's finish this thing. We're almost done. All right, so let me double check. Yeah, okay. All right, so the area of the segment equals 16 pi times 1/4, or 1/4 of 16 is 4, so this is 4 pi. Or you could put this over 1 and multiply across, which 16 pi times 1 is 16 pi. 1 times 4 is 4, so this is 16 pi over 4, which is 4 pi, which I'm going to go ahead and simplify it because I'm starting to run out of space. But if you want to do that step and then this step, that's perfectly acceptable, you guys. So this will be 4 pi. Let me just double check. Yep. 4 pi, and then minus 8. And we currently cannot combine these, you guys, because if we have a pi, we can't really combine it to something without a pi. Like, I can't say 4 minus 8 and then slap a pi on the end. That doesn't work out. That's when the demon cats get you. So, currently, I don't have any like terms. So, guess what, you guys? This problem is pretty much done, which I know you're like, this is really irking me, which if you wanted to get like an approximated answer, you could do 4 times pi, which is about 3.14. So you could do 4 times 3.14 minus 8, which we know 4 times 3 is about 12, and 12 minus 8 is 4. So the area is about 4, if you want to do it that way. But we're going to leave it in its most precise units, which now I'm confused because I have 2 different units. I think the demon cats got me, and I think it was originally just meters, not centimeters. Gee willikers, Miss Long, what's wrong with you? So my units are in meters, so I'm going to put my final units in meters. So it's 4 pi minus 8 meters, and since we're dealing with area, which has 2 variables involved, like this one had radius times radius, this one had base times height. So since we have 2 variables, we have a squared. All right, so guess what, you guys? Whoa, I just completely butchered my problem, but that's okay. Our area of the segment is 4 pi minus 8 quantity meters squared. Nice. Now, this one is very similar, but I am going to make you watch it because finding the area of this triangle is going to be a little bit more difficult. Okay, so I am going to make you watch all of it, but if you get to a point where you feel confident that you understand the problem, I highly encourage that you like zone me out and like mute me and try it on your own. I pinky promise, it will not hurt my feelings. So let's get going on example 7. Nice job, you guys.